Hello everyone and welcome to this Git and GitHub for Beginners workshop. This workshop was brought to you by Codelabs Academy. In this talk we're going to introduce Git and see why it's so essential to learn. We are going to see some use cases and examples to see how useful it is to learn Git and GitHub. We are going to talk about the terminal and discover some useful commands. Then we are going to start learning how to use Git and GitHub to maintain the history of our project. My name is Mo and I'm a web development instructor at Codelabs Academy. Git is a version control system. This means it can do things like create checkpoints of your code so you can revert back at a later point. And also so you can have multiple developers work on the same code base at the same time and still be able to blend or merge their changes together into the final product. A simple benefit of a version control system like Git is that you can view all the last versions and revert back to them. Imagine you create a program that works okay, but the next day you try to improve it and suddenly nothing works anymore. So if you use Git, you could compare the current source code to the old one and see exactly where you made changes, just like this picture. For example, you can see that we have green green background lines and lines with the red background. These lines are deletions and these ones are additions to the file on the project. For example, this render.tsx file. So we can review all the changes done inside our projects line by line on each file before actually approving the changes and adding them to our final product. You can do that again and again as you like and whenever you wish. A more complex thing that a VCS can do is branching. Imagine you and your friend want to program a word processor. You already have a basic program running, let's say version 1. Let's say your friend wants to implement a PDF export feature. You want to give a copy of the version 1 source code to your friend. Then let's say they write the PDF export feature and you maybe want to do some bug fixing at the same time using your own machine. It's only logical if you both later want to have a code base that contains both your bug fixes and the PDF export function of your friend. Let me tell you this, without using Git and GitHub, this may become a little bit tricky. If you use Git, your friend would create a branch from the main code base so you can both work on the same source code. You two would later merge the branch that your friend has created back into your main branch. Using Git and GitHub makes this whole process a lot easier and also records what happens in each save or commit you both do so people can later understand which feature was introduced when and by whom. This way, you can also work on two features at the same time. For example, you can have one half finished work in one branch and then switch branches to work on other stuff without the need to comment out all the unfinished code. The clever part of version control systems like Git is that it can merge changes from multiple people into the same file. Sometimes it can't figure out what's the right change, then it becomes a conflict. The developer checks the before and after code and determines which is correct. It does more than this, but these features are the primary reason it's becoming essential to learn Git if you work in an environment with multiple developers all working on the same code base. Now, GitHub is online storage for Git. It's designed to let people share coding projects with others. It's primarily useful when you have multiple people working on the same code base and you want to keep track of those changes and review everyone's individual contributions to the project. On GitHub, you can see all the files and their source code, and you can see the contents of each snapshot or commit. Additionally, if a project is public, you can clone the repo yourself, make some changes, and push it to the same project. And the author of the project can then choose to accept your changes, and that's how you contribute publicly to a project. Now, before we start using Git, you need to head to this git-scm.com/downloads and download Git for your OS, okay? Now, don't think a lot about these GUI clients. For now, we are going to use Git on the terminal. So if you're using Windows, you can choose this link, Mac OS here and Linux here. Before we start using Git, let's talk about the terminal and discover some useful commands. What basically terminal allows us to do, if you don't know much about it, it allows us to explore and manipulate the file structure using commands. For example, we are exploring the same folder here, so C workshop CLA/workshops. C, workspace CLA workshops, we can see that this folder is empty. Now, if I want to create a new project, what we typically do is to right click here, new, then new folder. There is a command for this using the terminal. We can use make dir. Okay, so make a directory called project. And we can see that we have now the project folder created right here. We can do ls. So ls means list. To list all the contents of this folder, we can only see that we have project here. Typically, if I want to change the directory to look inside this project, I can just double click right here and see it. There is a command using the terminal to do that as well. We do that using cd. Okay, so change directory to project. Now we are inside the project. We can list the contents of this project using the list command. Okay, so ls. We can see that we have nothing here. Okay, so empty line means empty folder, no contents. Now, before we start maintaining the history of our project, we need to initialize a Git repository inside that folder. We do that using the git init command. Okay, so after using the git init command, we can see that we have a hidden folder created. This folder is provided by Git, and it's where Git actually saves all the changes in our project's history. You might not be able to see this folder here because it's hidden. If we type list, okay, we see nothing because it's hidden. But if we type list with an A option, we can see our Git folder right here. Now we can maintain the project history while we are working on it. Let's introduce some changes first. We use the touch command to create a new file. Let's create a new file named names.txt. You can see that we have our file here. Okay, now how can we see if a change has been made inside our project? Git, of course, can track the status of the working directory and indicates whether there is a change that needs to be tracked. We can do that using git status. So using git status, we can see that we have one untracked file, this one. So the color is red, means that you need to actually add this file to the staging area before it can be saved. Now, this process of saving the changes inside our project history might become a little bit tricky. Let's use an example to really understand the process. Imagine you're a photographer, and let's say you want to take pictures for a yearbook at school. So how is this scenario going to play out? One way to do it, on a micro level, the person whom you want to take a picture of will get onto the stage at a studio or anywhere else. That's the number one step. You take a picture, step 2, and then save it, and then the person will leave that stage and the picture is saved in the yearbook. In this scenario, how does Git actually relate? So we have created this new file names.txt, but for now, no one actually knows who created this file and when it was created, because it's actually untracked. Git is not tracking the changes concerning this file. So we need to tell Git explicitly track this file and save it on the next snapshot that we are going to do. Now similarly, if you are a photographer, you're going to get that person into the stage. Now this names.txt file, we need to get it into the staging area before actually committing it. Now to do that, we use the git add command. Okay, so git add actually accepts two things. We can do a dot to actually add all the files to the staging area, or we can explicitly type the name of the file. Now if we type git status, we can see that this file is now staged, or these changes are now ready to be committed. Now let's say you changed your mind and you don't want this file to be tracked anymore. We have a command to add the files to the staging area. We actually do have commands to remove those files from the staging area as well. We do that using the git remove -- cached, then the name of the file. Now if we do git status, we can see that this file is now untracked again. Now the change that we have made in this case, we created a new empty file. We want to save the first snapshot in our project history. We do that using git commit. Now remember, before doing the commit or doing the snapshot, you need to add this untracked file to the staging area. Now the state of this file is changed to staged. So these are the changes. Git is telling us, hey, these are the changes that are going to be committed next. Now we can commit this change to our history. When committing a file, Git will take a snapshot of all changes that are staged. That's why we use git add before committing. When committing, we can also type a message that describes the changes that we have made. For example, let's type added new file, or we can type initial commit. Okay, so this is how you commit your first snapshot. This is the command. So git commit and then the message you want to commit it. Now if we see git status, we see that now our working directory is clear again. Now we have our first snapshot committed into the project's history. We can check the overall project history using git log. Okay, we can see that this is a commit. Okay, this is the ID of that commit. Don't worry much about this head master right now. We will see that in details next. And you can see the author, the date, and the message for that commit. Okay, now how about we add some new commits? Let's first create a new file using the touch command, and let's name our file hello.txt. We can check the status of our working directory using git status. We can see that we have this hello.txt file, which is untracked. We first need to add it to the staging area using the git add command, the name of that file, and then we can, before committing, let's see the status again. We can see that this file is now ready to be committed. We use git commit command, then the M option, then the message for this commit inside the double quotes. Let's type as a message added new file. Type enter, and we have our commit saved in the overall history of our project. Here it is, added new file. Awesome. Okay, now let's say we want to remove a commit from the history of the project. We actually use the git reset command to do that. But to actually tell Git which one to remove, we take the ID of the commit before the commit we want to actually remove. So I want to remove this commit. So I want to take the history of my project back into this state or this version. So I want to delete this. I grab the ID of the commit before that. Then I type git reset and then the ID of the commit. So remember, we are taking this ID, okay? Now if we type git log, we can see that we are back to the previous version of our project. Let's create this out and check the status of the file. We still see this hello file, but actually this change is now untracked. Before it was committed, now it's untracked, okay? Now so far we only have removed that commit from the history of the project, but we can still see this file right here, okay? So if we type git status, we can see that we have this file as an untracked file. So we did not lose the changes, we just rewritten the history of our project. Now I want to show you a new cool command using git to actually stash the changes that you actually need but you don't want deleted. So let's say I want to save this change, whatever it is. It's just now a new file created named hello.txt. Let's say whatever change I've made, I want to save it for a later point and grab it again and use it on another commit. We use that using the git stash command. First, you actually need to add those changes to the staging area. Okay, git status. Now let's stash those changes. Okay, saved working directory and index state. You can see that this hello.txt file was removed from the project. Okay, now let's do git status again. We see that there is nothing to commit, working tree clean. So we have successfully stashed the changes that we have made. Now let's say we want to grab those changes again. So I want to grab all the changes stashed again into the directory that I am working on. We use git stash pop. Okay, so now we are popping our stashes. See how cool it is? Okay, now let's stash those changes again. And let's say we have some changes on the stash. We want to clear them out, okay? We want to clear our stash. We use git stash clear command. Okay, now to prove that point, we are going to use git stash pop to try and get back our stash changes again. And you can see that there are no stash entries found. Awesome. Now, before learning how to contribute on projects using GitHub, let's clarify one thing. It's really essential to learn how to use Git, whether you're learning web development or you're learning Python and want to be a data scientist. You won't be surprised if an interviewer asks for your GitHub username nowadays. Contributing to projects remotely is basically how code bases are maintained, whether it's open sourced or private product. By the way, if you're looking to learn data science, here at Codelabs Academy, we offer bootcamps that are open to professionals from all backgrounds. Whether you want to kickstart a tech career or join a data science team or launch a startup, Codelabs Academy specializes in intensive bootcamps that will supply you with all the skills you need. You can visit our website, codelabsacademy.com/campuses/remote, and you can see all our upcoming bootcamps listed right here. So we can see, like, for example, this data science bootcamp is actually 999 euros or 2 euros a day as in a discounted price. Okay, you can also see this one, structured query language or SQL bootcamp. It's actually 99 euros or 1 euro a day as in a discounted price. You can apply directly to each bootcamp that you want. Okay, visiting our website, you can also join our free workshops. Okay, we have some previous workshops recorded that you can play directly, and we have the upcoming workshops right here. You can register to any one of them, and you can see the dates for all the upcoming workshops as well. Okay, now let's head to GitHub and see how we can create an online repository. We can do that by going to this plus sign and then click on new repository. We can choose a name for our repository, for example, Git Workshop. We can set our repository as public or private, add readme file, add .ignore file. We will see that in just a second. And then we go and create our repository right here. Nice. We have now our repository created. We can see that this repository belongs to this user. Okay. Now what we want to do is to connect this online repository or this remote repository with our local repository created earlier. We do that by actually grabbing this link right here. Okay. Then go back to our terminal and type git remote, add, and then the name of the remote, which is origin by default, and then the URL of that remote. Okay. Now we can check all the remotes that we are connecting to using this command, git remote -v. We see that we have a remote called origin for the fetch command and the remote called origin for the push command. Okay, they are the same. So we are successfully connected to our remote repository. Now, what if we want to push our local changes to our remote repository? We can do that using the git push origin master command. Okay, so git push is just a command to actually tell Git, hey, we want to push the changes to a remote repository. The origin is the name of the repository we want to push to. Okay, remember we are linking our remote repository with our local one, and we are linking the same one for the fetch command and the push command. So we both fetch and push to the same remote repository. Now the master is the branch we want to push. So by default we only have this master branch. Git is telling us about it. We can check the branches using git branch. We only have this master branch right now. We are going to talk about branches in details next. Okay, now let's push our changes to our remote repository. As you can see, we have successfully pushed all the changes right here locally to our remote repository. We can check that out by actually going to our remote repository and then refresh the page. Now we can see that we have one commit, okay, done 27 minutes ago with only names.txt file inside it. Awesome. Now let's talk about branches in Git and see why we use them. I'm using this tool just to simulate actually working with Git using branches. So we have this C0. This C0 means commit 0. C1 means commit 1. Okay, commit 0 is the base commit or the initial commit. This is the second commit. Main is the branch we are working on. This star right here is actually a pointer telling us that, hey, you are working on this main branch. So every change you are making right now is actually concerning only the main branch or affecting only the main branch. Let's add more commits, okay? So git commit, and then git commit again. Now we have 4 commits or snapshot. Now to really understand how branching works, let's imagine you are working on this project which has 4 commits, okay? And you have a friend who's going to work on the same project as you, and you both are going to work on different features or different functions. So what you want to do is actually base your work from the same base, like C3 commit, okay? So we both take this version of this project and then continue working on adding new features, fixing bugs, whatever it is that you are doing. After finishing both your work, what you want to do is to have the same code base again, okay? And the same code base needs to actually include both the changes that you have done and your friend as well. So to do that, let's do a simulation first. Let's say you are working on this main branch, okay? Your friend hops in and creates a new branch. He called it feature, okay? Now the pointer or the head is still pointing to the main branch. The head is simply a pointer telling you, hey, you are working on this main branch. The head is pointing to this main branch. So every change that you are making right now is only going to affect this main branch, not this feature branch. So if you want to work on this feature branch, you need to actually change the pointer or the head to point to the feature branch. We can do that using the git checkout command. So git checkout, then the name of the branch you want to point to. Now we are working on the feature branch. So let's say your friend is working on the feature branch and he's introducing new features. So after each new feature, you make a commit, another commit. Now on the same time, you are working on the main branch. You are doing, like, let's say bug fixes. So after each bug fixed, you do a git commit and then a git commit. See, now this structure is where the branching name came from. So it's like this is the main trunk, this is a branch, and this is another branch, okay? Now it's only logical if you both want to have the same code base again after finishing both your features and the bug fixes. So what you need to do now is actually to merge the changes together into the main branch, right? So by merging all the features or all the changes together again into the main branch, you are having the same history throughout all the project again. So if another friend hops in again and wants to work on something else, he will have both the green features included and these bug fixes included as well. So you do that by merging the feature branch into the main branch, right? Now if another commit is introduced, okay, the work continues on the main branch. If another friend comes in, you can make a new branch starting from this C9 commit, okay? Let's call it feature 2. And then check out that feature 2 branch. And then you can continue your work. So git commit, and then after finishing everything, you want to check out the main branch again and then merge those changes. Awesome. So that's pretty much how branching works, okay? Let's see that in action next. Now before we can contribute on online projects, let's talk about forking. So what is forking and why do people fork? So imagine I see your awesome code on GitHub, then I can make a copy of that into my own GitHub account. I can then improve it or modify it to fit my needs. That is called a fork. If I think that I made a change that you would like to accept and merge into your code base, I can send you a message called pull request containing all the changes that I have made, and you can review every line added or deleted and decide to take those changes and apply them to a code base, or maybe request some additional changes using GitHub conversations. Now, this is a project that I have created inside an organization just to simulate exactly that. What we need to do first is to actually fork this project, okay? We want to actually add some changes to it and then propose or send a pull request to the author of this project so he can review the changes and add them or merge them to the main code base if those changes are acceptable. So let's fork this project, okay? Now we are creating a new fork. A fork is a copy of a repository. Forking a repository allows you to freely experiment with changes without affecting the original project, okay? So I'm actually going to fork this project, okay? This project is a public project that belongs to this workspace or organization, excuse me. Now this new project with the same name is going to belong to this owner, which is me. So that's the different thing right here. So we are forking a project from an organization to our own GitHub account. Let's create a fork. Awesome. Now we have a copy of that project right inside our GitHub account. What we need to do is to actually clone this project that we have on our account. Okay, so we clone it and work on it from our local machine. So let's copy this link. Let's clear this out. Let's cd to workshops again. Clear everything, go to workshop right here. To clone this project, we use the git clone command. Then the URL of that project. We have our projects right here, learning Git. Let's cd right into it. Awesome. We can see that we only have this file right here, just like the remote repository. So we can check out the content of that file using this command. So we can see we have this title, learning Git. What I want to do is actually change the content of this file and then propose my changes to the owner of that organization in that project so he can review those changes and then accept them if those are acceptable. Now, I am the same owner of that organization, so we can simulate this thing just fine, okay? Okay, so first we need to create a new branch based from the main branch. So we do git checkout. Git checkout actually just check out a branch from another branch. So you can go from branch A to branch B using git checkout. If you are on branch A, you type branch B. If you are on branch B, you type branch A, okay? We can do another thing using this command, which is adding this B option to create a new branch and then check out that branch at the same time. So let's create a new branch called feature. Awesome. We have switched to this feature branch. We were in the main branch. Now we are in the feature branch. We can check that out by typing git branch. We see that this pointer is actually pointing to the feature branch. So our head is pointing to the feature branch. So each change is only affecting this feature branch, not the main branch. Okay. Now, let's open up that file in VS Code. Let's add some changes, okay? Learning Git is awesome. Now let's quit VS Code, check out the status of this working tree. We can see now that this README file has changed state, okay? So now the state of this file is modified. It's not untracked because this is not newly created file. We have cloned this repository and we got the file with the repository from another commit, so now it's modified. To actually save our changes, we need to add this file or the changes to the staging area first. Then we need to commit those changes. So let's do that by using git add everything, then git commit added new line inside MD file. Awesome. If we check out git log, we can see that we have this initial commit first and then this newly created commit after. Awesome. Now, what we want to do is actually to propose the changes that we have made locally to the owner of that project from the organization, right? So not from my own project on my account, but the main project and the main author of that project. So we want to actually send the message. This message is a pull request. We want to tell them, hey, we have some new changes. We want you to review those changes and maybe even merge them to your main project if they are acceptable. So to do that, we need to first push our changes to our origin. We want to push this branch, right? So we are pushing this feature branch, okay, to the remote origin, okay, using the git push command. Awesome. If we go back to our GitHub account, we can see automatically GitHub is telling us, hey, feature had recent pushes less than a minute ago. You want to compare in pull request? Yes. Awesome. Now check this out. What we are doing right here is actually comparing the changes inside the feature branch from this repository, okay, the one I have forked earlier, and we want to compare them with the main branch from the organization repository, right? So we want to actually send our changes to the main author of the main project, okay? We can add some reviewers right here, assign ourselves, add some labels. We can do some comments right here. We can see the changes that we have made, okay? Now let's create the pull request. Awesome. Now, if you can check out this top header right here, we can see that we are actually browsing the organization's project, right? So this Learning Git project is from the organization, not from my personal GitHub account. Now, I'm working as the main author of that project, okay? I'm switching to that persona. What I want to do is actually review the changes made by this user. So I can see the commits right here. Okay, this is the only commit added with the pull request. I can click that commit and see the files that have changed and review the changes line by line. Okay, awesome. Now I want this changes to be merged with my main project. What I do is come here, then click on merge pull request, merge, awesome. I can delete the branch now, awesome. I can check out the main project, and now we see on the main project that we have 3 commits, not 1 commit, and we can see the changes that we have introduced to the README file. Now they are merged to the main branch, right? Because actually, if we go to repositories, check this one that we have forked, it only has 1 commit, right? While this one has 3 commits. So you might ask me, hey, why those changes are not saved in your project inside your GitHub account? Actually, we have explicitly told GitHub to, hey, compare the changes from the feature branch from this repository with the main branch of this repository, okay? So there is a way to actually update my branch right here to be the same as the main project. We can do that simply and easily by clicking this fetch upstream and fetch and merge. GitHub automatically do the hard work for us, and now our repository is updated and it's the same. It has the same history as the main one. Okay, so 3 commits, everything is the same. This is the ID of the last commit, and this is the ID of the last commit. Awesome. Now there's one more thing I would like to talk about. So when you are working with Git and GitHub, you don't want to actually commit to the main branch directly. You always want to add your features on separate branches. And remember this, each pull request can be opened for each branch. So each branch can have only 1 pull request, not 2 pull requests, okay? What we want to do, let's check out the main branch first, okay? Now, I want to delete the feature branch because I don't need it anymore. I can do that by using git branch d and then the name of the feature. Okay, now if we check our branches, we can see only the main one, right? Now what we want to do is actually update this local repository to be the same and to have the same history as the remote one, right? So here we have 3 commits. While in our local repository, we can check the log, and we can see that we only have 1 commit. So this is 2 commits behind the remote one. We can use git pull to actually fetch all the changes and then merge those changes with our local repository. Awesome. Now if we go check git log, we can see that we have 3 commits, and our project is actually, our head is pointing to the main branch, okay? So this is the local main branch. The origin/main is the main branch from the remote repository, this one, okay? Now let's see how a branch can only have 1 pull request open. So I want to create a new branch called test. Awesome. Now what I want to do is to open a pull request with some changes introduced. Let's say we create a new file called names.txt, and we can change the content of that file. Let's type learning Git is really awesome. Now I have saved these changes, quit the file. Okay, now if we check Git status, you can see that we have one untracked file, names.txt. We need to add this file to the staging area. Okay, now commit the changes. Awesome. Now we want to push our new branch, right? Now after pushing this test branch, we need to do the same thing again. So let's compare in pull request. Okay, assign up myself. This is what I have done. Create a new pull request. Awesome. Now I'm working as the author of CLA workshops, this organization and this project. So I'm checking this open, okay, pull request. We see that we have only one commit, one file changed. To demonstrate that a branch can have only one pull request open, if we check the status of this working tree, we can see that it's clean. Now I want to create another file called hello.txt. Okay, add it to the staging area, then commit. Awesome. Now if I check the log, we can see that we have introduced, after the branch main, we are actually ahead with 2 commits locally. Okay, so let's push these new changes again. And after pushing the changes, we can see that now only our pull request, the open one, has updated. Okay, so we can't open like a new pull request for the same branch. The same open pull request will be updated whenever you push other changes to that branch. Awesome. Okay, so if we see the commits, we can see that now we have 2 commits, not one. The files changed. We see both files, hello.txt and the names.txt file. So hello.txt is empty. Awesome. Now what if we want to actually remove that last commit from this pull request? How can we do that? We can do that easily by removing this commit first. So to remove this last commit, remember, we need to take the ID of the commit before it. Okay, now we do git reset to that commit. If we check git log, we can see now that we only have one commit after the main branch. Okay, add a new file. So the last commit was deleted. We can still see this hello.txt file. Okay, we can check this right here. So now the file is back to untracked state again. What I want to do is to first stash those changes. Okay, now I want to update my branch right here remotely, my pull request, and to update it with the local changes that I have just made. So I have deleted one commit from the local repository, and I want that commit to be deleted on the remote repository as well. How can I do that? All I need to do now is to push the changes again. So by changes, I mean deleting that commit and stashing or deleting that hello.txt file. So I need to push my branch again, but using this force option, okay? Otherwise, this won't work. GitHub will tell you, hey, you have a commit missing. You can't just push this to the remote one. Now, this has been finished successfully. We can check that now we have only one commit. So we have deleted that, that commit successfully. Okay, now the files changed also is only one and not two. Awesome. Now I can accept this again. go to the pull requests, see this pull request, checking for ability. Now this branch has no conflict with the base branch. We can merge these changes successfully. Awesome. Now we have 2 files instead of 1. Okay, now what if we have some different commits, like for example this one and this one and this one, and we want to merge all those different commits into one simple commit. Can we do that using Git? Of course we can. Let's simulate that by creating a new file and a new commit for each file. So let's do touch 1, git add 1, git commit added 1. So I've added new file, okay, and I have committed the change as well. So we have a commit with this message added 1. My working tree is clear. What I can do is create the second one, add the second one, commit the second one. Okay, now we have 2 different commits, okay, with a simple change in each one. So we only have added a file and we have committed that change, something like easy and simple. We want to merge both commits in one single commit. For example, one single commit with a message of added file 1 and 2. So to do that, again, we need to take the ID of the last commit before them, okay? So if I want to merge these 2, I take this ID. If I want to merge these 3 commits, I will take the 4th one, okay? So let's copy this ID, clear out the terminal. Now, to do that, we use the git rebase command. So git rebase interactive. So interactive only actually provide us with a simple and straightforward way to edit those commits. We can edit them, edit the message, squash them. By squashing, I mean to merge a commit with another one into one only single commit, and other stuff as well. We will see that right now. Okay, so when using interactive as an option, you can see all the commands that you can use when rebasing. Okay, so P for pick, R for reward, E for edit, S for squash, fix up, exec, break, drop, etc. I want to merge both commits into a single one. To do that, we only need to pick one commit, okay, and then squash the other one. So S is short for squash, use commit, but meld into previous commit. Now I need to save my file and then exit the file. Okay, now GitHub will actually tell me, hey, you can add a message for this new commit that we are going to create. Added file 1 and 2. Now I want this as a message for my new commit, which contain both commits. I'll save again, exit. Okay, successfully rebased in updated refs. Let's clear this out, check git log. Awesome. We can see now that we have these 2 commits merged into one single commit. So we have both our files right here, and instead of 2 commits, 1 for each file, we have one single commit containing both changes. Awesome. Now, another thing I want to show you, this is the last thing we are going to talk about in this discussion, in this workshop. Now, earlier we have mentioned that version control system like Git can merge changes from multiple people into the same file, and sometimes it can't figure out what's the right change, and then it becomes a conflict. The developer needs to check the before and after code and determines which is correct, okay? So we haven't yet talked about how to resolve conflicts and what are conflicts. So let's do that right now. What I want to do is to create a new branch. Okay, just bear with me for a second. Let's call this one A, and let's create another one called B. Okay, now we are in the B branch. Let's create a new file, or let's just edit the names.txt file. on the B branch. Okay, so right here I will say let's add new line. Okay, changes, let's type changes from B branch. Save it, exit. And then we add the change to staging area. We commit this change. Awesome. Now let's check out the A branch and do the same thing. Okay, so nano names changes from A branch. Awesome. Let's add the change to staging area and commit it as well. Okay. Now we have both changes committed. Okay, so they are both saved into the history for each branch. Let's say we want to merge branch B with branch A. Okay, so Git is going to tell us that, hey, you have a conflict right here. Both person or developers from both branches are changing the same line. Which one do you want to choose? Do you want to keep the line from branch A of the developer A, or you want to keep the changes from branch B from the developer writing on the branch B? So let's do that. Let's merge A with B. Now it's first it tells us auto merging names, but then hey, conflict. Merge conflict is in names .txt, automatic merge failed, etc. Now we need to fix those conflicts and then commit again to actually resolve the conflicts and keep that history maintained. Okay. Now if we open up the project history inside our VS Code and go to this name, we can see now that Git added these changes for us. Okay, so remember we were working on the A branch right here, right? So the current changes are from the A branch, okay, and the incoming changes are the one from the branch we want to merge into the A branch, which is the B branch. So logically Git is telling us, hey, you have these current changes, okay, and this is the incoming changes from the other branch. Which one do you want to keep? Okay, using VS Code, I can just choose to resolve this conflict right here. I can accept both changes. I can accept the incoming change or accept the current change. Let's accept the incoming change. So we are accepting the changes. We are telling it, hey, use the line from the branch B, not the line from branch A. Awesome. Now if we save this and go back here, check Git status, we can, so if you follow the hints given by Git, you won't actually be confused. Okay, so Git is telling us, hey, you have unmerged paths, fix conflicts and run git commit. Okay, I've fixed the conflicts. I need to first add the names, add the changes, and then commit these changes. Okay, fixed conflicts. Okay. Now we can see that our working tree is clean. And did we merge successfully? Did we completed the merge successfully? Let's check that out. Let's see the content of the name.txt file. We can see that on the second line we have the changes from B branch. So indeed we have successfully merged the changes on the B branch into the A branch, and we have resolved those conflicts by choosing explicitly which line we want to keep and which line we want to delete. We have chosen to keep the ones from the incoming changes, so the ones from the B branch. And pretty much this is the same idea when you are working on Git and GitHub with any other branch. So if you are working on the main branch and you have a conflict that you need to resolve, it's going to be the same thing. You can also resolve those conflicts using GitHub on the website, but actually you can do them both and maybe choose what works for you best. Okay, so this is the end of this talk. So thank you very much everyone for tuning in, and see you next time. Bye bye.